Hi, good morning. Hi, good morning. We are going to start this second lecture regarding powder metallurgy for beginners. This is a short course that it will compose by 4 lectures. The first one was developed previously, and it was devoted to what is powder metallurgy, field of applications, advantages or disadvantages of the technology as powder metallurgy. Today, we will devote this lecture to a different topic, which is the sorry, let's start again. So this second lecture we will devote with the historical background of powder metallurgy after we have seen in the previous one the topic what is powder metallurgy, definition of the technology, field of applications, advantages and disadvantages of the technology. So today we will talk about the historical background. So if we have to see where powder metallurgy starts in the history of the man, of the human being, maybe we can say that the first time that metal powders were used to develop tools or to develop jewelry or to develop things was in the ancient Egypt, in Africa, where they use some kind of sponge iron to produce some tools. Maybe later we can tell that in the Inca period they have used also some grains of platinum, some even use some powder of gold or silver or other metals that they can find in the nature, and they heating a little bit these powders they can forge in some way and to produce some jewelry also and some small tools. So later we have a lot of examples. We will go into more detail later, but maybe we can talk a little bit about the platinum powder forged into coins. It was developed in the 18th century, in the 19th century, and others. But here you have a list of possible milestones, possible important milestones in the development of the powder metallurgy industry. We will go in the next slides more in detail with as my concern could be the most important milestones. You can find this in the ASM handbook in the volume 7. This extensive table. So as I mentioned before, maybe Egyptians were the first people to use metallic powders to develop things. The Egyptians, it was 3,000, more than 5,000 years. But we have another important milestone in India. This was in the 300 years after Christ, and in this the Delhi pillar, it was built in more or less in the year 413, and maybe solder, because this is some inscriptions you can find on the basement of the pillar. This pillar is 7 meters high, about 15 centimeters in diameter, and it has the weight is in the order of 6 tons, and it's a typical place for all the metallurgists to go for as a pilgrim place, because you can find this pillar as an example of many technologies in the material science field. For instance, this pillar is usually put as an example of the first forged material, because it was made by iron particles forged. Also, this pillar you can find this pillar as an example of corrosion, because this pillar has survived for many centuries, and it was made by plain iron in principle. So plain iron in the severe conditions like it's in this part of India, that you can have a very non-positive weather to survive for iron. And despite this pillar has been surviving for many, many centuries. So it's an example of how protection in corrosion could be developed by a natural way in this case and can protect the material. But also this pillar could be considered today the first part produced by additive manufacturing. Why? Because this pillar was supposed that it was made with a sponge iron powder, more than powder. It was very small ingots of agglomerates of powder that was forged slide by slide from the bottom to the top. So in principle, it was an additive manufacturing product. So maybe we could include it also in the additive manufacturing books. So, but anyway, it's included always in the corrosion books, in the forging books, and many other places, because it's a symbol of how metallurgy was developed in that part of the world in that period. So, but also we include as a principle of the powder metallurgy technology, because they use iron powder and they built it from iron powder. So in the 19th century, in the 1800 year, in this order of this age, it was developed both in Russia and England, different coins produced by press and sintering, coins made by platinum, by copper, silver, or even gold. So these sintered platinum coins developed in the 19th century were used to produce ruble coins by press and sintering. In this case, in that case, sometimes were made by platinum. It was the unique way. In the previous lecture, we mentioned different fields of application of powder metallurgy. And there is a lot of field of application in which the powder metallurgy is the unique way to produce the material. In that case, in that period, it was impossible to melt platinum to produce coins, and they did it by press and sintering from powders. After that, it was a very important milestone, which is in 1910, the development of tungsten filament by the Coolidge process. What they did is to replace the carbon filament in the lamps, in the light lamps, by tungsten filaments. They modify completely the industry of the lamps, and because by tungsten they can provide a new material that can maintain the lamps surviving for many, many hours, much more than with the carbon filaments. And in that case, it's also an example of the unique way to produce that material in that period, because tungsten has a very high melting point, and in that period it was not possible to reach this level of temperatures. So the process, how they produce the tungsten filaments, they built bricks of ores of tungsten oxide. They put inside in a furnace, in a capsule, in which they apply a current flow from the two places where the bricks were subjected to the furnace, and passing through to the brick of oxide, tungsten oxide, they reduce in a nitrogen atmosphere, they reduce the tungsten oxide, and they produce small ingots of tungsten. So they did it for a certain time, and at the end of the process, they have small ingots of tungsten that were submitted later to hot extrusion and then to drilling, to another different process to produce the tungsten filament. So when they produced the tungsten filaments, it was in some way the beginning of this another very important milestone in the powder metallurgy industry, who was the cemented carbides development. Why? Because to produce the tungsten filaments, they need dyes to produce this wire production. And they use in that period diamond matrix. So diamond matrix were really expensive and not easy to prepare. In this way, in the order of 1925, there was developed the so-called vidia, that in German means as hard as diamond, from another different material who were the tungsten carbide, cemented carbides. So the first thing was try to produce tungsten carbide as a material to replace diamond to produce the dyes to produce also the filaments. So it was not easy. They did it from tungsten carbide, reducing the tungsten carbide by flows of carbon monoxide, sintering at high temperature, and then they can produce the tungsten carbide. Tungsten carbide was very difficult to sinter, and they thought in sintering with a binder of a metallic phase that they test different metallic phases like nickel, like iron, or any others. But at the end, the unit that really provide a good microstructure and a good process was cobalt, by different reasons that we will explain maybe in another lecture. So the race to get the vidia, this material that was called vidia in that moment, it was really, really long. It was a lot of different patents, different improvements to the process. And at the end, at the late 30s, we had the product in the market. This product, it was based especially in this microstructure, a microstructure in which you can find a hard phase, which was the tungsten carbide, and a binder, which is a soft phase that was made of cobalt. The unique way to produce this material, is by powder metallurgy, because you can, of course, you can take tungsten carbide and cobalt, melt it, and produce an ingot casting tungsten carbide. But the microstructure will never be such this one, in which we have perfectly distributed the reinforcement of the carbides in the binder phase matrix. So this is also a captive way in terms of the field. So in this way, the first hard metals product was cutting tips or valve cones, valve inserts, wire drawing. Of course, this material was developed for drawing dyes to produce the tungsten filaments. So in that case, one of the first products produced by this material was wire drawing dyes to produce in the same way tungsten wires. So it was a really an important milestone, not only for powder metallurgy, but also for the industry in general, because the cutting speed increased in many orders of magnitude. At the early 19th, in the early 20th century, we can produce at very low speed in terms of cutting metals. But when we develop the cemented carbides, we increase from, let's say, 10 meters per hour till 10 meters per minute to 14, 400, 500, even higher speed to produce materials by cutting, by machining. So the hard metal industry was spread in Europe in the 50s by different countries, thanks to the development of these cemented carbides. First was in Sweden, then in France, then in Austria, Italy, United Kingdom, Benelux, also in Spain later. So after this important development, which was the cemented carbides, in the 30s were developed another materials, which was the bearings, which is, as I put as an example in my previous lecture for beginners, as a combination of the three main fields of application, because bearings is a porous material that is really cheap to produce by powder metallurgy, which combine the best possibilities of properties for this application, and also is the unique way to be produced, because in the bearings we have a porous material with a very well-controlled porosity inside in order to capture the oil for the self-lubricating bearings, and with a microstructure fully optimized for these applications, for the applications of the bearing materials. So it was developed in the 30s, many kind of bearing contents, even magnets with this configuration of microstructure with a well-controlled porosity. And this was another example, another important milestone in the powder metallurgy industry. There is another important fact, is that at least in many countries in Europe, all the main companies who later were considered the leaders in the industry of powder metallurgy in the 60s, 70s, 90s, even in the 21st century, all of those big companies start to produce in the 30s, 40s, even 50s bearings. It was the first part that was produced by all the big companies, all the big companies that today are in the core of the market. So after the bearings that were developed in the 30s, we have to review that maybe the first important milestone was the Coolidge system tungsten filaments, then the cemented carbides, then the bearings and contacts and magnets. And in the late 30s, before the Second World War, was developed in the United States the first material, the first part produced by iron powders and press and sintering. And it was the first General Motor oil pump. This oil pump was introduced in the cars in the late 30s. Powder metallurgy of iron appears in that period like a way to reduce cost and reduce the use of raw materials. You have to think that we were at the beginning, and we were just before the Second World War, in which the saving of materials and energy was really important in that moment of the industry. And for this reason was introduced this manufacturing way to produce some parts. So between the 30s and the 60s, there were developed many simple shapes and different materials in the car industry, producing the growing of the conventional powder metallurgy industry of parts produced by press and sintering. In the 60s, in between the 60s and the 80s, it was the big development period in which they increased a lot the level of density in the materials from 80% to 91%. The technology were introduced a lot of new things like new alloying systems, the pre-alloying way to introduce the alloying elements. It was introduced a lot of technology in the press part of the process with presses with multiple effect. It was introduced the powder forging, and of course it was introduced also a lot of control in the sintering furnace that allows to produce parts with much higher density. This higher density allows to produce even better parts and more quantity of parts in the cars. From 80s to now, we increase a lot the reliability in those parts. We can reach 94, 95% of the theoretical density. A lot of new problems appears like cracks in green compacts, surface decarburation, oxidation, but we have a lot of new tools to afford these problems, new lubricants, controlled atmospheres, new technical advances, and so on. Even the introduction in the late part of the last century of the modeling, both in pressing and in sintering. Modeling can predict a lot of defects and can help us, the designers, to optimize the process. Today, we have more than 100 different parts in the car industry, and those parts belong to the different systems in the automobile, like engine, the steering system, the transmission, and others. Maybe this is one of the most important. One of the most important milestones in the PM technology after the cemented carbides developments. So this is a short lecture just to have a general view of the history of the powder metallurgy technology. If you have any question, please, you can do it through the YouTube channel or through my email, and I will be very glad to answer you. Thank you very much.